Hey guys, today we will learn about the generator, capability curve. Yeah, little bit, you know, um, complex, but we can, figure it out. So what I meant is if we understand, watch every single of lectures, now we can understand it easily. You know what I mean? Don't need to struggle to memorize. You know what I mean? Let's see. First of all, there's a to make a capability curve for a generator. There's a uh, basically for mainly restrictions. First of all is the thermal restriction. So it could be field winding, armature winding, and overheating the end of a stator iron core. We say retaining ring here. You know what I mean? Retaining ring here, we say. When it's a lagging current. About this number three, I will make one lecture, okay? Don't worry about it. So first, there's thermal restrictions. So field winding and armature winding. Look at it here. So as you guys can see here, field li limit, right? And here, amateur, IS, amateurs. Also, restriction here. You know what I mean? We will say this too. Because it's winding, you know what I mean? It has the limitation for heating. And here's what I said is the stability limit because of the retaining when the current is lagging. About it, I will tell you later, okay? Just, yeah, gotta be more familiar. The result is, because of the lagging current, the retaining is gotta be saturation. You know what I mean? Uh, retainings, it gotta be saturation. So that's why the flux is gotta be here. You know what I mean? The result is, yeah. And then second part is previous lecture I explained the static stability limit, right? This torque angle I will say also, right? So it cannot over 90 degrees. When it's over 90 degrees, what happened? It's out of control, right? And we generally operate between 20 to 30 degrees, right? For safety, right? And the last part, the left two part is one is mechanical strength of shaft. You know what I mean? So where is it? Here, for example, here is generator, right? And here we make it turbine using turbine like a wind or water, right? It's make it pulse, like right, make it turbine rotating. But here, this connector, this is we say shaft because of the mechanical strength. It's also limit. And the last one is power factor. You know, so which means I'm not sure I explained a lot about this or not. So by the way, why we actually use you know capacitor bank or to improve power factor, we use you know we do lots of things. But why? Because we wanna reduce the line current. You know what I mean? Yeah, that's it. So which means if we improve power factor, which means we reduce the line current and loss. You know what I mean? But it's also indicated the reactive power supply and observations capacity is also reduced because we are focusing on sending and generating the active power. You know what I mean? That's it. I hope so you guys understand what I'm saying. You know what I mean? So previous lecture, you hear static stability limit. Uh, so let's look at it, why we have this picture. So first of all, we need to make a voltage equation. What we need to do is first of all drawing the equivalent circuit, right? So E equal here's I, right? And then here's JX, and then here's load, right? But in this case is amateur reactance, right? I ignored the R plus JX. Here is a resistance in the Y line, and this is also leakage reactance, right? Because mostly this amateur reactor is 99%, you know what I mean? So we could neglect. So we draw the pager, right? But since this pager is, look at this, so here's V. So E equal V plus I J X S. And this is reference point V, right? So generally, our power stem is, we use, you know what I mean, motors. So that's why lagging current, right? Here. So we add it here, and this is what we made now. So look at it here. If we add a triangle here, so I say is yeah, you guys can see this angle is the same, 90 degree. Here is theta, right? Theta same here and here. So we will say IJX is cosine, right? Cosine, here's P, and here's sine, right? Q. Yeah. So we made it now P and Q, right? But we just, port, no part. This is we make turning, like from picture one here, and we just, turning, and it gotta be picture two, right? And we move into the ported, symmetrically, just port. You know what I mean? Like this, port. Yeah, because of our interpret, you know what I mean? We wanna know how it looks like. So look at that. Our general power system is here. So we wanna make it P and Q, right? But in this case, number two situation, what happened here? P is minus side, right? But we generally interpret like here, right? So that's why here we port and symmetrically. So here is and P, no. So we make a piece here, right? The plus part, right? And P and Q. So we will, yeah, we port just, you know what I mean? Yeah, that's why. And yeah, here's one thing I didn't tell you guys. First of all, you guys may familiar with this equation. E equal 4.44 N F and pi F. So this is how many windings we wire, and this is frequency, and this is excitation. You know, I mean, current is flux, right? So which means I pi. I pi is since we use a synchro generator. What is that? We need to use for excitation. We need to use a DC voltage, right? So what I meant is here. E is related here. This line is field current. You know what I mean? IF. But here, this line, this I is a related armature current. You know what I mean? So if you guys can see here, let's see. Here, I said field winding and armature winding. And we could also see it here, right? So now, yeah, so now we are folded and symmetrical, right? And then I said was this angle, this angle, torque angle, right? Torque angle is equation. What was it? XS and E V sine delta, right? It cannot over 90 degree, right? So the next part is here. So look at that. This triangle, number 1, 2, 3, 4. This triangle, we move to here, right? Same, right? So what I wanna say is here, guys. Here's I said is here, this part, what was it? Field. And this is armature, right? So actually, look at that. So there's a line, right? So with the radius, we actually draw like this, Not, perfectly, but also here, from here, you also make it this. You know what I mean? So it make it circle. And what I wanna say is here. So, guys, sorry. So it could be added to here. You know what I mean? So there's a thing. So like we add it here, and then we circle make it like from here make it like this, and from here this armature field, and then we make a circle like this. So when we make a circle happened like this, so I will show you know how to draw it. Alright, I wanted to explain first. So what I wanna say is, first of all, I said that there's a thermal restriction, right? First of all, it's armature, here, armature and then field, right? So that's why here, armature and the field here, right? This is not really matched, you know what I mean? Just I wanna explain, right? And then third part is what I said was here. You guys can see here. End of the, retained link, stability limit here, right? So actually this line, third, where is this third line is, the limit, stability. So, and then I said here's also prime mover limit, right? Yeah, that's because of that, our actual, uh, uh, generated curve is like this. You know what I mean? So if you just see this picture, you guys cannot understand it. It's more easier. Look at that here. So I said here, when you add this triangle, right? This is now just the angle is like this. Sorry, I was trying to find out the right picture, but I failed. Sorry about it. So yeah, I make him lots of pictures. So what I wanna explain is one. So look at the here. So right, and the picture was here, right? And here's delta torque angle, right? And here is I will do it with that. Let it theta, right? So theta and delta, right? So because of delta, we just change the position. Do you know what I mean? So we change the triangle's position. So this delta, it cannot over the 90 degree, right? From here to here, right? Or if we add it like this, it cannot reach 90 degree. That's why there's a stability, steady state stability limits here. It cannot over 90 degrees. You know what I mean? And then because armature and the build wires, capability for heating. That's why there's a, we make a circuit like this and this. So since the field, as you can see, this, field windings limit is more longer, right? Compared to the armature, right? So since we make a circle, both of them, standard this lengths, right? So like this, no, sorry, like this, and then like this, right? Like this, like that. So it's only covers this in common part. You know what I mean? My drawing is not now like not good right now. But what I mean is I wanted to you guys show you guys how we draw this generating curve. You know what I mean? Generator curve. You know what I mean? Capability. Yeah, today's lecture is yeah, that's all. It's not that easy, but just try to do. If you guys wanna more deeply understand it, I will make it, more deeply about it. But this lecture is, at least my concept. At least you need to know about this. You know what I mean? That's it. Have a good weekend, guys.